with online, I can open up the tab and just like get on my phone or like play a game or something like that. It's a lot harder whenever the person's like staring at you.
Yep. I'm definitely with you. That's it is harder for me too online because I'm just talking to myself, right?
Yeah.
Especially the last year, spring, when there was no in-class options. You had to do everything online. Yeah.
That was not fun.
It wasn't fun, no. And we only had like 200 cases.
Not a lot.
We have millions of cases now. Okay, let's begin. We are going to continue talking about equations of motion, or EOMs, applied mechanics, and I just want to make sure we are all on the same board, on the same page when it comes to equations of motion. So I just want to rewrite them. And this is the most general form of equations of motion, as I said. Most of our work in this class is not going to be focusing on this very generalized form of equations of motion. Okay, so I'm going to start with the forces first. W sine of theta plus A of x is equals to m du dt minus WQ minus V of. Okay. And then we have W cosine of theta, sine of phi, AY. These are the aerodynamic forces. Hopefully you will remember these. And dV dt minus plus UR minus WP. And we have W cosine of theta. Yep, it's cosine of theta, cosine of phi plus A of Z equals to M dW dt plus Vp. Let's actually do this because you all have this in your notes. I want to ask any of you to give me the rest of the equations. The moment equations, right?
Mx Cg equals Iz minus Iy Qr plus Ixz PQ.
PQ, right? Okay, what else? You are missing some parts of it, aren't you?
I thought that was what we simplified. I mean, I guess the dP/dt, and I thought we canceled those out.
So we are looking for the most general terms.
So, okay, so dP/dt, Ix,
And
I think that was all that was left off. Ixz drdt plus PQ.
that's right. And the dRdt plus PQ. Okay. What else? M of y Cg is equals to
dq dt Iy plus Ix minus Iz, all that times PR.
times VR.
PR. plus IXC times P squared minus R squared.
Okay. Even QR here. And what about the last one? Just trying to guess it based on the pattern. What do we?
Like no looking?
Yes, just based on the pattern we have here, right?
DRDT,
Okay.
IZ
IZ,
plus IY minus IX, PR. No, sorry, not PR. QR.
PQ, right?
It repeats.
It should be PQ, right?
I was looking at the wrong spot, yeah. Then it's IXZ times P squared minus R squared. It's the dPdt minus QR.
dPdt minus QR. Is this true?
Yes.
Yes? Okay. I remember the equations for myself. Yeah, and this guy. So this is the most general form of the equations of motions that we saw in the previous lecture. As you would imagine, we are not going to work with this form of the equations of motion, right? So we wanted to find the most general steady motion, which was called the helicoidal motion, right? Essentially moving like this. What did we do? The first thing we did was it is a steady motion, so all the time derivatives are going to go to 0, right? I'm going to keep these equations like this here on the left side of the board. I'm just going to work with this right side of the board. And the equations we eventually came up with, I'm pretty sure we have all of those here. But the only thing we really need to do was to take the time derivatives out to get to these final equations. Right? Okay, this was for the helicoidal motion. But then the question is, can we simplify those equations even a little further? Or let me change the question. What are the aerodynamic forces that we need to include, right? Because in these equations, we are just referring to aerodynamic forces as aerodynamic forces, right? So let me actually write the force equations here. You're going to get W sine of theta plus A on X M cos MWQ minus VR. Right? What will be the second term here?
W cosine theta sine phi plus AY equals UR minus PW.
EW. And this last term, cosine theta, cosine phi, AZ equals to M, VP minus UQ. Right? So we have these three force equations for equations of motion. Right? But we don't know what are the aerodynamic forces that are present here. So what do you think we should include in the aerodynamic forces? And it's determining the aerodynamic forces. Let's think about it. What do we have?
I'm sorry, what does that say about the spiral?
Helicoidal.
So we have friction. We have,
Friction.
wait, hold on, I think I misunderstood the question.
What are the aerodynamic forces that are present here?
Oh.
That's A of X, A of X, A of Y, A of Z. What are, okay, that I didn't expect you guys not to answer this question,
Yeah.
which is interesting. What are, like, give me some aerodynamic forces.
Drag.
Okay, drag is one of them. What else?
Thrust.
Okay,
Lifting.
lift. So the main aerodynamic forces that we have always dealt with are lift, drag, and thrust, right? And we usually do the resultant force as R. Then we earlier in this chapter we included thrust in these aerodynamic forces. Okay, so let's see which of these are present in each direction. What do you think we are going to see in the X direction for aerodynamic forces?
Drag and thrust.
Drag and thrust. Okay, so exactly. So we're going to get negative D plus thrust. But it's going to be a component of thrust, right? In the X direction, because thrust can be, we have talked about the thrust vectors and all of these things we have seen before. Cosine of beta. Okay, what about the aerodynamic forces present in the Y direction? This one's a little tricky. What are we gonna have in the Y direction? So in the Z direction, is definitely going to have lift, right? This is a component of lift. This is going to be your Y and X direction. What are we gonna have in the Y direction?
The wind gust.
The
Wind gust that goes sideways.
the side, exactly. That's it is called the side aerodynamic coefficient or side slip aerodynamic coefficient. So we're gonna have the S that will be present here. We're gonna have another component of thrust, which is going to be cosine of alpha t. So with respect to the thrust vectoring, we're gonna have the cosine projection of it and then sine of beta. And what about A of Z? What do we have there?
Lift and weight.
Lift and weight. Does thrust have any component here?
Yes.
Exactly. It's going to be T sine of alpha T.
Why is lift negative?
It depends on direction. So the direction of Z is actually in this direction.
Okay.
That's,
So then is weight kind of lumped in with lift?
no. Weight is already here. We didn't include weight.
Okay. Yeah.
Yes.
For the side slip and the thrust vector in AY, how do you know which way is like negative?
It really goes back to the definitions you're gonna have. So you have to look at it from that plane that you want to write the forces on. Okay. For example, when you're looking at when you're looking at the y angle, you essentially have to look at the projection of motion on that angle, right? And then take one of the directions as your principal direction. Based on that, you will change this negative sign. You will choose the negative sign, and then because it is changing direction, right? The changes in direction will be determined by the sign, right? Because it will dictate the negative and positive sign to your thrust eventually. Does it make sense?
Yeah.
So that negative sign you're correct in saying that the negative side is changing, but it's changing based on your principal thing, right? And based on the sign of beta. And S, this sign here is determined based on your principal thing, because the wind gust is not changing its angle. Right? It is going to be in the same direction no matter where you are, right? So you have an angle, the wind gust is usually against that principal direction, if that makes sense. Okay. So we have these three forces, and that's it. Or is that it? Let me ask you. Are we including all of the aerodynamic forces that we can include? Or are we missing anything here? Just think about it. What do we have in this type of helicoidal? And let me rewrite this. What do we have in this type of, what kind of force do we have?
Centrifugal?
Centrifugal, right? You said centrifugal? What did you say? I didn't hear.
I think I said centrifugal.
Okay, same thing, right? Centrifugal force, right? The point is, in a rotational motion, you will have a force that is directed towards the center of your rotation center. But how should we calculate that centrifugal force? Who remembers what was the centrifugal force?
Isn't it the angular acceleration?
Angular acceleration multiplied by your mass, right? Okay, so let's call this C. Your mass is going to be W divided by G. And what is the angular acceleration here? Does anyone remember from dynamics?
Like what it is in a non-angular form?
Yeah,
That acceleration times radius.
acceleration times radius.
Radius acceleration divided by
It
radius.
is actually V times omega, right? But this is not the thing that we are interested in.
Oh, velocity is not acceleration.
Okay. So does anyone remember? What was the centrifugal acceleration? It was V squared divided by R, your curvature, right? Your essentially V squared multiplied by the curvature, which is 1 over radius.
So it's
Cosine squared of gamma.
I thought W was
W is weight here.
Oops.
Yeah, that's
You're
it.
thinking of lowercase omega.
Yeah.
Yeah. That I usually, whenever I do use lowercase omega, I usually do this to make it distinguished from W. So you have weight divided by G, which is going to give you your mass, and that component of centrifugal acceleration in the direction that you are interested in. So which directions that does this force, is this force effective on?
Doesn't it change?
I meant which coordinates axis. So is it going to be X, Y, Z, or
It's just gonna be
do we have any centrifugal force in the X direction?
I think so.
No.
Don't we just have it on the wall?
We have it in the Y and also in the Z direction.
Why is it not the X?
Because of the angle mu.
Because X is tangent to your curvature.
Mm-hmm.
So it'd be completely 90 degrees to your X. And if you do a cosine with 90, then you're good.
Thank you. So you're going to have a component of your centrifugal force in the y direction and another component in the z direction. That's actually this, yes, sine and cosine. C cosine of mu, C.
What is mu in this?
There is, so this may have been the reason. This is my mistake, sorry. This is going to be your x, this is y. And this is your aircraft that is moving. Right, so you're going to have centrifugal force in this direction and also some in this direction. Does this make sense? No, Lawson?
Yeah.
That was my mistake. Pardon me, are you asking
I
something?
was asking what the mu was.
Go back to your notes. Give me the angles. What are the angles you're going to get? Then you go back to your notes. It should be there in your notes.
How far back?
Okay, so we didn't talk about these angles?
We talked about theta, sine, phi, but nothing else.
The theta,
Okay.
the phi, and the other one.
So you don't know what is angle omega then, right?
Yeah, and
We touched on it.
Angle gamma.
gamma is the one we also think of.
Okay. So, angle, okay. Huh. Are you sure? I have it in my notes.
I see an omega, but it's with the translational vectors.
Did we talk about the coordinate systems at all? Different, like the frames of reference.
Kind of.
Yeah.
Like one is on your earth, one is on your air, one is on the body, right? ZA, Z, like all of the XA, X. What are the angles between those? The earth angle. Did we talk about the angles between those? Right? Because they're gonna make an angle.
I think when I talked about the flight path and direction angles, the angle of attack and the horizontal angle, that was the last that we covered after the theta, phi, and the other one.
Yeah, all those angles. So the angle mu is actually the angle between your the aircraft, the airs, the flight path, the angle between flight path and the Earth surface. And angle gamma, which we're going to see later as well, is going to be the angle between your flight path and the plane's angle. Let's call it plane, aircraft.
Like angle of attack.
No. Flight path versus the, that, we'll come back to the angles later today, okay? Just take mu as the angle between your flight path and the Earth surface.
And gamma is the same gamma we used in the centrifugal equation.
Yes.
Okay.
I can't believe you didn't cover this. We have to back up a lot. Don't worry about it. So, let's move on. And this is an assignment I want to give you. We have the helicoidal, you just plug this in, you have the final equations. In the helicoidal motion, we are assuming QR and P are actually 0. So everything is going to be equal to 0. Just plug these forces in, you're going to get your equations of motion, right? That is going to be your most general form of steady motion, right? But the next steady motion we want to talk about is going to be a steady, straight, non-slipping motion. So a steady, straight, non-slipping motion. Or what? Okay? And we want to use the equations of motion to get there. Your moments are going to be 0. None. So the only equations you're dealing with are these 3. So start from these 3, simplify your equations to get to your final steady, straight, non-slipping motion.
You said we won't have any moments.
Yes, all of those are going to be 0. That's by definition, actually.
So then our equations are just a function of aerodynamic forces and weight.
That's correct. Okay, let's do that. Think of it as a attendance quiz.
Don't just make the right-hand side 0 and move over the variable. Of the first 3 equations.
Okay. I mean, if you know the solution, then do it.
What do you need? You want me to go up there and write it?
No, on your papers.
Oh, okay.
This is a quiz.
Are you not gonna have the slip in the Z and the Y then?
This is non-slipping, right?
On something?
Yeah.
So those equations will change.
Yeah. That's the idea.
In this situation, is W weight, or is this the is W the K component of velocity vector?
Okay. A lot of letters here. So W, which W? This one?
The other one on the left side, yeah, where it's like the cosine.
All of the W's on the left side are your weight. So this is sigma F equals to M A, right?
Okay.
Here you will see components of velocity W. Here you will see weight.
Okay. Wait. So the W's on either side of the equation are different W's.
Yeah.
Oh my god.
I'm sorry. But there's nothing I can do about it. Okay, so we have just make sure we have this. So what do we have? Are we still working on it? Or are we done?
Let's see.
What do we have? There you go.
Have AX equals W sine theta, which simplifying AX is negative drag times thrust cosine alpha t.
Okay.
Since beta is going to be 0, cosine of 0 is going to just be 1, so eliminate that term.
So T cosine alpha t, right?
Yeah.
And what else?
And the cosine b drops out because there's no side slope angle.
Yeah.
That's what I have. Oh, and that, yeah.
Equals to 0. Right?
Yeah.
What else?
AY equals negative W cosine theta sine of phi equals negative thrust cosine alpha t.
Negative W sine of theta. And what else? I'm sorry.
Oh, it equals negative thrust cosine alpha t.
Equals to negative thrust sine alpha t. Okay, what happened to lift and drag?
Well, the drag was in the x direction.
Well, you see, I didn't hear you.
That's okay.
What about lift?
No, that's in the z direction.
Okay. So, actually, why is this on the other side of the equation? So this is, that's what you said, right? Is this the correct format of the equation of motion for a steady state non-slipping flight?
I'm kind of confused on the second equation.
So do you think it should look different? I just wrote down whatever Igor told me. If you think it's wrong, you can have your own opinion. Yes.
Why is the first equation just negative d?
No, I just added negative d.
Oh. Very confused.
In one direction, it's just negative drag. That's it, guys.
What?
In the industry, we call negative drag. Yes. I'm just a little confused on the whole T sine alpha T. Because if T sine alpha T is still connected to, oh wait, hold on. Is that the Y equation or the Z equation?
The y equation.
That's the Y. So then, if
Well, I
it's
guess
sine-
it's the z equation. I like left is in there, so never mind. That's the z equation.
Which one? This one or this one?
The second one,
Second equation.
since it has left, it has to be the z equation now.
okay. That's what I was confused about, because I thought it was the Y, that's not sine beta.
No, did you say there's lift in there? I just wrote down whatever I thought you were telling.
Yeah, that's good.
It's good. Okay. Do we have any other differing opinions here?
Isn't the
Yes, we have one.
the one with lift supposed to be the W cosine theta W or cosine psi?
I didn't hear you. Can you?
Isn't the equation with lift in it supposed to be the W cosine theta cosine psi?
Cosine theta and cosine phi.
Yeah.
And then it's,
Okay, so tell me what to write. That's what I'm asking you guys.
I have W cosine theta cosine psi minus L minus T sine alpha T equals 0.
Okay, let me. repeat what you said.
Is W cosine theta, cosine psi, minus L.
Cosine
minus-
psi,
Yeah, is that what you're looking
That's fine.
at?
that's
Oh,
why.
phi, sorry. Minus L minus T alpha T, or T sine alpha T equals 0. You know,
Okay.
sine-
What about the other one?
For the y equation, I have W cosine theta minus S minus T cosine alpha T sine beta,
That's pretty
or
long.
whatever it's called.
That's equals to 0.
Yeah,
And these are the two equations you have? Or do you have any other one?
I have the one that looks pretty close to, or no, it's the same as Igor's on top.
So keep the drag one, get rid of the left one.
Yeah.
So, but where is the lift in these equations? Ah, it's over there. Okay, yeah, I just saw it. Okay, so it's actually good. I thought this may be a little less confusing, but it is. So let's see, what's the problem with any of the either Igor's or Nicholas's?
So the second one of mine is completely wrong, so it needs to erase that one.
This one?
Yeah, just get
Yours?
just get that off the board.
Okay.
The second one of next needs to have the S equal 0 since we don't have any sides left. It's
That's correct.
straight.
That's true.
Then sine of beta is
There's
going to
no, this is non-side slipping.
then the sine beta in that equation would be 0 because their angle is going to be 0 for side slip as well.
Was
Okay.
that established? The beta was the side slip angle?
Once we talked about alpha being the angle of attack and beta is the horizontal angle, aka the side
There
slip
it is.
angle.
Okay. Now I see it.
And for that equation, it's W cosine theta times cosine phi. Okay.
W cosine theta
Just add the cosine.
It is cosine phi.
The one below.
here.
Yeah.
Yeah.
And then I think it should be squared away.
So it is equal to 0 then, right? Is that what you're saying?
Should be.
Wait, say that again.
Because beta is 0, sine of beta is 0, so this whole thing is 0, S is 0, W cosine of theta multiplied by cosine of phi is 0 then.
Let's see.
Well, if it's your z direction and you're in steady straight flight, then you shouldn't have any forces moving you up or down. They should all only move.
This is the y direction.
This is the
This is
y.
why. Oops. Okay. Yeah,
So
that
then-
shouldn't happen.
Hold on, it's sine of phi.
Let me try to
Okay.
help you a little bit. Just forget about these equations. What do you think should we have here? It is a straight, non-slipping flight.
Thrust and drag.
Thrust and drag and lift and weight, right? And how many equations do you think it should have here? Two, right? So one of these three equations should go away, right? Based on what you're telling me, is
Probably
essentially,
the y direction one is 0.
pardon me,
The y direction one is 0. So that's the side.
this is the y direction, all right?
Yeah.
I don't know.
But if you're going straight, all you have is lift and thrust drag. So it's like z and x. That's all you got, right?
Just forget about the coordinate systems, because if you want to go into that, it will make it a little messy, right? Just let me put it this way: just forget about the equations of motion we have, and try to write down the equations you think are going to be applicable here. We have an angle of attack, we have a thrust vector, and we have a flight path angle, right?
You said it's steady straight flight?
Yes.
It's straight, why are we worried about the angle?
Okay, can anyone answer that question? If it's a straight flight, why are we worried about the angles?
Because just because it's straight doesn't necessarily mean that angle of attack is 0.
Exactly, that's it. Doesn't necessarily mean the thrust vector angle is 0. Doesn't necessarily mean the angle of attack is 0. Okay, so with having that in mind, let's rewrite the angles. But don't look at these equations, and let's rewrite the general equations you want to get. Of course, we are going to have a. So what are the forces that can have components in the two directions? Let's call them x and y direction, right?
Lift, weight, drag force.
So all of the forces are going to have components in the directions. What are you putting your frame of reference on?
Z and the X.
Let me ask you this other question. Have you talked about the importance of frame of reference in your dynamics? Where to put it, and how is it going to change your analysis and all of those things?
Yeah.
Okay, so you want to write a force balance system, and you can essentially write the force balance system based on any frame you want to have, right? Okay, it doesn't really matter to me, whatever you want to choose. And we have three main different ways of choosing the frame of reference. One is going to be your earth, right? The earth surface can be one frame of reference. One can be your flight path. One can be the let's call it the coordinate, right? So we have three ways. Let's put it on the flight path, right? What does it mean? When you put your frame of reference on the flight path, what is it going to mean?
To the center line of the aircraft.
What does it mean for the forces?
Can you rephrase that?
If you put your frame of reference, so your coordinate axis, on the flight path, what does it mean for the forces? These forces are going to have components with respect to the flight path. These forces are not going to have components. Or do we have any forces that is not going to have any components?
The weight's definitely going to have.
Okay, the weight is going to have components. Okay, that's correct. What about thrust? That depends on your thrust angle, right? So if you have a thrust angle, you will have components. What about lift and drag?
Those are either perpendicular to your flight path or.
So they won't have any components. It is either going to be full lift or drag or zero, right? Does it make sense? So based on this, let's rewrite the equation of motions. I just want to make sure that we are not confused. Just don't look at these equations, this helicoidal, anything. Just very simple. Try to write the force balance for a steady, a straight, non-slipping motion of the aircraft. And I also want to draw this for you, just to make sure we are all on the same page when it comes to angles. Because these angles names may change as we go forward. Because different books have different names for the angles, right? We just want to make sure that we are clear on what we are talking about. So let's assume this is the direction that is perpendicular to the Earth surface. So Z of E, which means that this is the direction of what? Which force? Weight force. Okay. Okay. And let's say, and also this is the horizontal axis. We have the flight path. Okay. And then you have your x of A, x of B. You remember what x of A and x of B was, hopefully. So flight path. The angle these two make, your flight path and x of A, is going to be your thrust vector, alpha of t, or thrust angle, let's call it thrust angle. The angle we're going to have here between x of B and x of A is going to be angle of attack. This angle is going to be gamma. And what else do we have? And this whole angle is theta. What else do we have? That's it.
I feel like we kind of skipped over XA, XB, and then gamma.
Pardon me?
Theta,
We did a skip over them?
I think we did. And I think alpha T as well, but I just assumed alpha T was thrust angle, but
What did we talk about in the previous lecture?
we went over the translational, rotational. We touched on flight path and direction of aircraft, angular velocity. Then we went translational, did some matrices, vectors, and then we went to the moments and stuff in the helicoil.
Okay, so we have three different frames of references, right? We can have this coordinate system, XA, YA, ZA. We have XB, YB, ZB, and XE, YE, ZE. This one is the Earth coordinate system, right? So they are essentially putting your frame of reference on the Earth. What does it mean? If you're moving on the Earth's surface, you're essentially moving in the horizon direction. Right? You're assuming the Earth's surface is not a curve, right? Does it make sense? This one happens when you put, I think we talked about this too. But I remember, this one passes through your aircraft. Essentially, that's what we call, this is the frame of reference that passes, that lays over your core. Didn't I say that? I think I did though. And this one lays on the direction of air. So A stands for air, B stands for body, earth, E stands for earth. Is it clear? Okay. So based on this, we have these angles that these two make with each other. So the angle x of A and x of E is going to be gamma, right? X of A, and this is x of E, which is perpendicular to Z of E. And like the angle, of course, we can understand the angle between x of B and x of A is alpha, and the angle between x of B and x of E is going to be theta. This is for a two-dimensional case. In a three-dimension, we are going to bring in the angle mu, all of those other angles that we have seen, right? In a two-dimensional case, we don't have all of those angles. So based on this, what will be the equations of motion for a steady, a straight, non-side-slipping, non-sided? Let's do the x direction first. Something that you need to keep in mind is that x, y, and z, how we name all of these coordinates, can change, right? So don't get confused. Just based on one, do the analysis based on one figure, right? For the next figure, for the next problem, you just have to create a new system, frame of reference. So we're going to talk about the frame of reference a little more in orbital mechanics, a lot more in orbital mechanics. So we're going to go back to dynamics and remodel it. So,
So we're just going off the X and Y axis. The W would be in the sine theta.
okay, so we are gonna go on X of A axis. So X of A is going to be our frame of reference and Y of A, right? So what will be the projections of W on X of A and Y of A?
Projection of W on X of A and Y of A.
And Y of A, right? That will be the frame of reference.
Sine theta plus 90
Sine, on which one? Sine theta plus 90?
for W.
So cosine theta plus 90, right?
I would say sine theta.
Sine theta. Oh, you said sine theta?
If it's with respect to the XA axis and you're finding W's component, yeah, I'd say sine theta plus pi over 2.
I didn't hear you. Answer it. Repeat that.
Oh, well, if it's with respect to the XA axis and the distance from XA to XE is theta, sorry, XA to XE is gamma.
Gamma, that's correct.
Okay, so then sine gamma plus pi over 2. Because if you're taking it,
So what you're telling me is that the projection of this on this is going to be sine of the angle between them multiplied by that vector.
yes.
Okay. Do we agree? All.
No, I don't agree.
So what is the projection?
I don't know.
Okay.
I just know it's wrong.
That's one step in. I don't want to say in the right direction, but in another direction. We're gonna figure out later if it's the right direction
I
or
think
not.
one of the signs is wrong though, because it's going from left to right. There's a projection on the XA is on the left and Y is on the right. So I think one of the signs is supposed to be negative.
Which one? One of the signs. We only have one sign though.
I think negatives.
So you're saying it is a positive then.
Yeah, maybe positive.
Okay. So let me just isolate W X of E and X of A. This is the angle gamma. This is 90 degrees, right?
Just cross some triangles. So
Can you draw the Y of it too?
So is okay.
Just for
That's Y of A.
so the angle between Y of A and W is the same angle as XA and XE.
That's correct.
So I don't really know why we're adding pi over 2. Can't we just do?
You could do it in terms of X.
Yeah, can we just do it? What you're saying?
Yeah, you can do it in terms of X. You could take gamma and then do it off X. You even need, wait.
Okay. So that's okay. So let me ask you this. You have two vectors. This is actually important because you have to make sure, right? This is like you have the angle between them. Let's call it angle E. What is the projection of this vector on this? So this, let's call this angle A, vector C, right? The projection of this vector on this is going to be A cosine of B, right? So let me, you can actually make it much more simpler. What is the angle between X of A and W? That's gamma plus pi over 2. So what is the projection of this on this coordinate, on this axis? It's going to be W cosine of pi over 2 plus gamma, right? You were actually very far.
Oh.
Because there are only two options, either sine or cosine, right?
Well, I knew the angle.
So we're projecting W onto X of A, is that what you're saying?
Yeah, because we are writing the force balance for X of A, right?
Okay.
In that direction, right?
Sounds
Okay.
good.
Which means that what is going to happen? What is cosine of pi over 2 plus gamma?
It'll just be gamma.
It's the same thing as sine of gamma.
Yes.
the
Why
same.
do we even, well, what's the point of that?
You have to do it with respect to XA.
No, what is the point of y?
To get the cosine first, if you know it's sine of.
Because he was being confused. I just wanted to make sure I clear his. I knew you were going in the right direction. I just wanted to make sure his confusion is clear. But yes.
So hold on, the answer was W sine all along?
Pardon me?
The answer was W sine all
Yeah.
along?
So you were correct. No, the answer was not W sine
It was W sine
of gamma. So the angle was different, right? It wasn't gamma plus pi over 2. Okay. So we have. Wow.
Yeah.
Pardon me?
So we need to go back to statics.
Yeah, back to-
I think so. That's because.
Too many angles, they're all crisscrossing over others. Very confusing.
Yeah, that's definitely correct. But you're not gonna deal with these angles that just once or twice. We have one. I don't know if you saw the YouTube comment. I didn't see the YouTube comment. We can't see the right side of the board.
Oh.
Okay. I'm sorry, guys. I'm sorry. What happened?
So is it just the vector projection? That's cosine just because it is.
Pardon me. Let me just fix it. We are already at the end of the class, so I don't know how much is going to last.
No more angles.
But okay, what was the question, Lawson?
I feel like this is just a general vector thing, but just a vector projection of one vector onto another is just the cosine, right? That's where I was getting confused,
Yeah.
because I was trying to think of it like,
So let me put it this way. Let me actually answer his comment. I'm not going to clear anything on this side of the board, so you don't need to worry about that. But they're not seeing that side of the board. Yeah, I guess I had to move this chair. Okay, so projections, right? Let's go back to projections. If you want to project a vector on one of the axes, if you have the angle of on two axes, essentially, want to find a projection on a vector on the two axes, x and y, x and z, whatever the two axes are. If you have the angle between that vector and that axis, your projection is whatever that vector is multiplied by the cosine. If you don't have the angle, which means that the angle is pi over 2 minus theta, right? That projection is going to be sine of that angle. Okay, that clear? Okay, so yeah, we moved much slower than I really anticipated. I want to give you all of these conditions, then you give me the final solutions. But which is all right. So W sine of omega in x direction. What else do we have in the x direction?
We got a thrust in the X direction.
We have thrust. We have a component of thrust, right? Because thrust is alpha t and it is in the direction of b thrust, right? So what is the component of thrust in that direction?
This is the projection of alpha t onto X of b.
On xy. So thrust in this is in this direction, right? You want to find
yeah.
t cosine of alpha t.
But then also drag in the X direction. Just the full length.
Right. What are the signs here?
Minus, plus, minus. Yeah.
That's it. Right?
Yeah.
Okay. In one of the directions. You were actually, Igor was moving in the correct direction at the beginning, but I guess we all were confused with the three-dimensionality of these equations and some of the angles that we didn't really go over. Pardon me?
I didn't have W sine angle, but I had the rest.
Okay. Okay, so what else do we have? What is the other equation of motion in the other direction?
Z direction, since you have your weight and lift forces.
We have lift, full of that one, so plus lift,
That's actually Z on. Okay, so lift,
no components. Then we have weight, cosine of gamma. And
rate, cosine of gamma. So you are saying that L minus,
yeah, and we have the thrust, which is thrust sine of alpha t. There we go. We're done.
that's it, right?
I think so.
What is the sign?
Lift plus thrust minus weight.
Okay. There's a very small but here, that the direction of our Z is in this direction, right? Which means that you're gonna get a plus sign for W and minus sign for the rest of it.
Oh, it's positive, yeah.
Okay? And it's positive downwards. That's it, right? But I mean, all of the other way of looking at it would have been fine as well. Okay, so let's move on. We have did we talk about angle of roll? What was angle of roll?
Phi.
Okay. I was looking for the answer, but let's forget about it. It is not going to appear. Okay, so let's move on to the next special type of fly. And this time, I want you to give me the answer in like 5 minutes. The other one is the steady straight side slipping fly. So we have the side slipping. The only part we don't really have. And instead of just the angle of roll is actually, or we have two different angles of roll. One is when your aircraft is rolling, one is when it's rotating. So that's two different angles. The other angle of roll is, or a slipping, right? The other angle of roll is the new one that we talked about. Okay? So we have the same thing, except we have side slipping. So it's not going to be non-side slipping. What is going to change here?
You'll have an S in an equation.
Okay.
Beta.
That's one thing that's going to change.
We'll also have beta.
We will also have beta. So what is going to, okay, so let's do that. Let's do this. Let's find the three equations. What do we need to add? First of all, is it going to be a two-dimensional case? Not anymore, so it should be three-dimensional. So we have to have three equations. And let's try to find the three equations. Let's try to see what's going to happen in this direction. That's the drag direction, right?
Nothing should change in that direction.
Which part of it is changing?
You have cosine.
You have cosine beta attached to the thrust.
Okay, so this will be exactly multiplied by a cosine of beta. That's the part that should be added here. Okay. What else?
On the drag direction, or just like the
No, this is the drag direction.
Yeah.
This is correct. That's it.
Okay.
We need to add parts to the other equations. You can actually go back to that and take a look at those and get inspiration from those equations, right?
Add the cosine of phi to the weight.
Okay, cosine of phi, which in this case, because we are not really rolling, is going to be cosine of mu, right? But this, like when you're solving an equation, you know which angle. This is just a roll angle, the angle that you're rolling.
You also add S. No,
Where do we have to add S?
To the
Here?
equation.
to the Y equation.
So this equation then, right?
There it is.
I don't think better than that. Don't we just create a whole new equation? Since it's 3D now, we need a third equation.
Yeah, like, third one, so it's like that begins.
Okay.
The system again?
The first one's X, the second one is Z, we need the Y. Right?
Oh, okay, sorry. So then Y would be, well, let's fix Z first.
Is there anything else left to fix?
You have to fix it.
Is there anything to fix?
I don't think so.
No size left, no. No, yeah, there's no beta in Z. There's no
Do you have any centrifugal force?
No,
Why not?
because you're not,
It's not held.
You're in
helicoidal.
steady flight.
You're not what?
You're not helicoidal, you're in steady flight.
We are not rotating, right?
Yeah.
But we have forces in that direction though. So why don't we, because it is, we are slipping, right? We have a slip angle. Why don't we have centrifugal force?
Because we'll have a third equation.
We're gonna have what?
We'll have a third equation for Y that'll handle forces in that direction.
But does it mean the centrifugal force is zero though? Having a force in the other direction doesn't really mean that you have to remove or add the centrifugal force. What is it about this specific type of flight that makes you say you don't have a centrifugal force? Because we have a force in that direction that is pulling things in, right?
Because it's
Or we're going
steady.
straight.
It is a straight,
Yeah.
right? It is a straight, right?
Mhm.
So essentially, whatever force you have in the other direction that is trying to rotate your aircraft is being counterbalanced with other forces, right? So what is it about a straight flight that makes the centrifugal force zero in a straight flight?
So like your thrust direction?
No,
Is it your relationship to like
it is a mathematical thing, right? What is your curvature?
zero?
Zero, which means that your R is going to be infinity.
Yeah.
So V squared over R is going to be zero, right? Centrifugal force zero.
Oh, okay. So it's the XA, XE in this situation, but it's not at a weird angle, it's level. So that way, I got it.
Okay. Okay, so what is the equation we have in the other direction then? We of course we are gonna have the side slipping force S, negative S,
Minus T cosine alpha T sine beta.
minus T cosine alpha T. This is alpha of T. This is subscript, yeah. Just make sure that you are clear on this. Sine of beta. What else?
Plus W cosine theta sine phi. I guess there's no roll. So,
Sine mu.
yeah.
Cosine beta or cosine gamma?
I'm saying gamma. Okay, so these are the three equations we have. Let's talk about the next case, which is going to be your flat term. What is a flat term?
Is that just only applying yaw and keeping
That's
the
it.
level?
So you're turning on the ground, right? So what will be the main equations here?
We just look to again, since it's not showing in the data presenting.
You have to speak up.
It would just be like X and Z, the same, like the two equations, since it's not varying in the Z direction any.
What about,
So we have, yes, go ahead.
what the thrust be varying in the Z direction? Is the yaw, so your thrust would be going in a different direction, you'll still need three equations.
So you're saying you will still have three because of, I don't know because of what,
The
but
thrust will need a different angle, right?
thrust will have different angle. Okay. So let's have a top view of an aircraft, right? We are turning, that's the idea. We have one person, don't give me the number of equations, give me the equations you think you're gonna have here. Or what are the changes we're gonna see in these equations?
Do we still have slip?
We haven't talked about a step, so let's do the most general form. But let's come to this equation first. What is going to happen to this equation?
Cosine beta is.
Cosine beta what? Let's talk about the weight. What's going to happen to the weight?
It's going to be no components, just straight.
It's going to have no components because we are essentially level with the ground, right? So there won't be any component. So
So this is like a taxi situation? Okay. Okay, you'll have negative drag.
on the tarmac, yep.
Okay.
So negative drag. What else do we have?
Thrust.
Thrust. We haven't talked about side stepping at all. So we're gonna keep cosine of beta in there. And thrust vectoring is in the direction that is dictated by your pilot, if you will.
Do we still have an alpha angle?
Alpha of t. That's what I'm saying. That's the thrust vector, right? Thrust vectoring angle. Okay. So that's how do we determine the thrust vector?
The difference between x and x.
No. Like from, let's say you're the pilot. How do you determine the thrust vector? Do we know? You haven't passed propulsion. Huh? But essentially, this is a vector that is determined by your jet engine.
Oh, okay.
The nozzle
So
on it.
your engine can. Okay. Gotcha.
Yeah.
Okay. What else do we have here? That's it, right? That's the first equation. What is the next equation?
No lift, no weight.
No lift.
Well, if you're on the ground.
It doesn't mean you don't have any
Well,
lift. Essentially, the only thing it means is that you may have your lift is being counterbalanced by other forces. Pardon me? Okay, so we are gonna have the negative lift, right? That's correct. But what you're telling me is that what about this thrust component in the left direction? Is it going to be present or not?
It depends on the vectoring of the engine.
So we cannot just remove it, right?
Yeah.
Because we didn't remove it here. So we have to include that. Cosine of alpha t,
And then we sine.
sine of beta.
That's the y equation then.
I'm sorry. That's what I was thinking.
So it should
Just
just be sine alpha t.
Sine alpha t. Sorry about this. And what else do we have here?
The weight.
The weight. What is the angle of the weight?
No way.
Straight down.
What is the angle here? No angle?
No way.
That's correct. So do we have any third equation?
Yes, you have centrifugal force.
And also we didn't like neglect the side step, right?
Yeah.
So let's do that here. It's going to be S negative thrust cosine of alpha t sine of beta. And what else do we have here?
Minus c cosine.
So it is a flat turn, right? We are on the surface. If we are not moving up or down, right? Just C, right?
So
These are the equations for flat term.
I'm still a little confused why there's a cosine beta attached to the thrust component. There's no roll, is there?
Beta, you're talking about beta, right?
Yeah.
No, there's no roll. But what is the angle beta? What is the angle beta, guys?
What's your side step angle?
Side slip angle. So if you, what is the side slip?
It could be something, or that.
What? So what is it? Like, give me an example.
Oh, that's like the angle you have to compensate for if you're in a free stream of air.
That's essentially angle of the wind gust, for example, right? Your aircraft is moving, there's wind gust coming in. During flat turn, we didn't assume the wind gust doesn't exist, right? So because of that wind gust, you're essentially, your direction of the flight path is going to be a little different, right? So the direction of thrust is going to be a little different from the direction of the flight path, right? Because of that wind gust, right?
So that's almost like the angle away from XE? Or
Yeah, like this angle. Okay.
So it's like if you were paddling across a river, you had to angle your boat to like counteract the flow.
That's a very good example. I think that's the best user-friendly example you can get for non-pilots like us. Like,
Yeah, I went back to physics 211 for that. I was on an exam.
okay, so
I got that one wrong.
I guess that's it for today's class, guys. What I'm gonna do for the next lecture, because I think we became a little confused. Eventually, it all came back and was fixed. I will go back to the frames of reference and will just mention them, right? This is this angle, this is an angle. And just make sure we are on the same page, and then we'll move quickly to the other topics, right? Because we are a little behind. Pardon me?
Will our homework be posted today?
Yes, because the homework it's either today or Thursday, but your home, I haven't designed the homework yet. Your homework is not going to be based on the equations of motion. It will be based on aerodynamic shapes.
Oh, so that's like 2 class periods ago.
Yeah.
When will that be due?
Next week. You will always have 1 week for the homework, unless something is specific. If you need an extension, you can always ask for an extension, but you should have to ask. You cannot just, at the morning of the class, you cannot just tell me that you need an extension, right? Sorry, the recording did not cover all of the, whatever that is.
I was wondering if your kid emailed
Second grade,
about
you got 2
the
apples.
materials exam.
Answer it. Your parents just
Why was it here?
You got 2
Yes, I did. I think I replied to your email.
Stupid hey.
I was just trying to lost the last lecture.
Hey, it works though.
Pardon me?
I was just trying to watch the last lecture. I didn't get to see it.
Yeah. I think at the beginning of the lecture, I tell that you send me an email.
Okay.
Yeah, if you.
Perfect.
Yeah.
Awesome. Thank you.
Guys, sorry the board wasn't covered.